I'm Kyler Foster. Have you ever wanted to learn about hockey? If so, come with me and I'll show you how. Let's go.
The slapshot is one of the three main types of shots in hockey, along with the snapshot and the wrist shot. Out of these three shots, the slapshot allows the player to shoot the puck with the highest velocity. Throughout this presentation, we will explore why this is and how players can achieve even harder shots with the use of advanced sticks.
Hockey players today can choose whether they want to use a stick made out of wood or out of composite materials such as carbon fiber. Historically, only wood sticks were used, but now most players have switched to carbon fiber. This is because of the advantage of carbon fiber technology that allows the stick to bend or flex against the ice, creating elastic force. This force is exerted in a forward direction along with the initial force applied. We will explore this and compare how the wood stick and composite compare in the amount of net force that they applied on the puck. First, we will explore the wooden stick and show how to calculate the amount of force that is exerted on the puck.
Before we get into these calculations, though, I need to explain that in order to be able to do these calculations, we need to make a few assumptions. One of these assumptions is that the ice has just been freshly resurfaced and is very smooth. This means that there is a negligible amount of friction between the ice and the puck or the ice and the stick. Therefore, the coefficient of friction will be 0. Another assumption that we have to make is that the air is frictionless. Air does cause a small amount of resistance to objects moving through it, but it is such a small amount that it can generally be assumed to be negligible.
Finally, we have to assume that our puck is traveling completely horizontal and that once it has left the stick, it travels in uniform motion horizontal to the ground. Since the puck is very light and only in the air for a small amount of time, gravity will have little effect on it, therefore uniform motion.
Overall, we want to calculate the amount of force that the wooden stick applies on the puck. To do this, we first need to calculate the velocity of the puck. First, to calculate the velocity, we need to find the average time of each of our trials. We excluded trial number 4 because it was abnormally lower than all the others and most likely due to human error. When we took the average of our 5 trials, the result was an average time of 0.19 seconds. Next, we found velocity using the formula velocity equals distance divided by time. We substituted our values of 7.62 meters and 0.19 seconds and ended with a velocity of 40.11 meters per second.
Momentum is the force that keeps an object in motion after an initial force has been applied to it. When an object has momentum, it will continue to travel until a force acts upon it in the opposite direction, or a frictional force acts upon the object, slowing it down until it comes to a stop. When an object has greater momentum, it will take a greater force applied to it in order for it to stop.
Impulse is a change in momentum over a period of time. When the puck is at rest and is contacted by the stick, it undergoes a great change in momentum over a short period of time. This causes an impulse.
Next, we had to calculate force applied to the puck. To do this, we used two equations, momentum and impulse. Momentum equals mass times velocity, or P equals mv, and impulse equals force times time, or I equals ft. In this example, we can assume momentum equals impulse. Therefore, mass times velocity equals force times time. Manipulating the equation to find force, mass times velocity divided by time equals force, or mass times velocity divided by time equals newtons. The mass we used for this was 0.17 kilograms because that's the average weight in the NHL of a hockey puck. The velocity we found earlier was 40.11 meters per second, and the time is 0.02 seconds. This is because that is the impulse time of when the stick is in contact with the puck. Substituting all of these variables into the equation, we get a final answer of 340.89 newtons. This point is when the stick is applying the force it has accumulated. The puck has equal gravity and normal force, as well as equal force applied and frictional force. When the stick comes in contact with the puck, the forces change. In this example, the gravity and normal force would be exactly the same, but the force applied would be much greater than the frictional force, causing the puck to overcome inertia and accelerate in the direction of the unbalanced force. If a player takes a slap shot and elevates the puck above the ice, the horizontal component of the velocity will be less than if the puck is shot near horizontal. Therefore, to get the highest velocity, a player wants to shoot the puck just above the ice to maximize the horizontal velocity, while at the same time reducing friction.
Now that we have explained the physics of taking a shot with a wooden stick, we will explain how this changes when using a composite stick. When using the wood stick, the only force that is being applied on the puck is generated through the swinging of the stick in a circular motion. With a composite stick, there is also another large amount of force acting on the puck. This force comes from the bending of the stick against the ice. As the player follows through with the shot, the bend increases until contact with the ice is no longer held. Then it snaps forward and increases the force applied on the puck.
Now that you've learned the physics of a slap shot, go out and apply these skills in a game and score some goals. Luke Winquist, signing off.
You broke it.
Told you I was gonna break it.
No.